So why, in this case, this is one of the examples that I use, and as an astronomer, why was this great revolution so long delayed? Because the Revelatory Commission needed to wait for, and here we have Edwin Hubble. And we needed Edwin Hubble to tell us a few things. The Revelatory Commission needed him to arrive at his scientific understandings before they could finish telling us, or begin to tell us their story. And so the first thing was
1923, that the universe was bigger than the Milky Way and contained millions of other island universes. 1929, that space itself is expanding. All galaxies are fleeing apart from each other. The further away, the faster the recession.
So science now provides the background for telling us something about who God is among the galaxies, not in an amorphous heaven, but God among the galaxies. Galaxies that are fleeing apart from each other in an enormous universe. So that stage is set. Here we have a series of images, with 21st century eyes, we instantly recognize these. We see that they are spiral galaxies, irregular galaxies, elliptical galaxies, and that they're all way beyond the Milky Way. And we take this for granted. We just know this. We learn it in grammar school. But almost 100 years ago, when Hubble took these incredible photos, and these photos are 100 years old. They are marvelous photos. So even 100 years ago, they were taking images of the universe as we currently see it today in staggering beauty. They just did not know what they were looking at. And they really thought that these fun, nebulous-looking images were embedded within our own Milky Way, and they thought that these were simply star-forming regions. There was really not a good concept. So this was so amazing that the Hubble Space Telescope was named after Edwin Hubble because of the work he did. So we're going to have to learn a little bit of science, because to validate some of the parallels that I want you to eventually arrive at about terminology, we have to take a look at Hubble's work. Andromeda. Andromeda is mentioned in the Urantia book, and it's significant in terms of how it's mentioned. Andromeda is our nearest neighbor. It's our biggest neighbor. It's like the Milky Way in size. And it was Hubble's favorite destination for probing his accruing understanding of astronomy. Here's a really curious understanding about Andromeda that you may not realize. This is just astounding. This wonderful image of Andromeda, which is clearly photographic, if the full moon in its path across the night sky were to cross Andromeda's path, the full moon would occupy only this big an area of Andromeda in the night sky. So if you could superimpose this photograph on the night sky and the moon and see it with the moon at the same time, Andromeda is many times the size of the full moon in the night sky. But it really, in a very dark sky conditions, you're able to get to some pretty dark sky. Andromeda is a nice little fuzz patch up in the sky. It doesn't look as big as the full moon, but it actually is that big. It is that huge, and it is that close. It's only 10 times its own diameter away from us, and it's enormous. So it was Hubble's favorite destination. And in this greater definition photograph, Hubble labels a few of the structures that he sees in Andromeda. He sees a star cloud here, he sees an open cluster here, he sees a globular cluster here, and a Cepheid variable here. And these are the kinds of objects that make up a galaxy. These are the primary objects. And I want you to notice the term star cloud. The label star cloud. The star cloud of Nebadon is referred to by name 3 times in the Urantia book. So think of the idea of Nebadon as being one of 100 local universe star clouds peppered around the shape of a minor sector galaxy. So you can see the shape, and it's actually fairly easy just to visualize how this grouping of star cloud stars, how there could easily be about 100 of those within any given galaxy in a geographical area. And again, notice the Cepheid. this slide, if you look carefully, and it's not, you really have to pay a little bit of attention here, because the stars in this view, some of them are blinking on and blinking off. They are dimming and brightening. And these variable stars, this is actually speeded up, they are key in Hubble's research because they're called Cepheid variable stars. And a woman astronomer back at the turn of the century was the one who really documented these stars, and they discovered at that time that Cepheid variable stars were really noted for having a correlation between their brightening and dimming. So Cepheids share identical characteristics of brightness versus periodicity. And as Hubble is looking out and he is seeing Cepheid variables brightening and dimming, and he's seeing them in Andromeda, he's realizing they have to be a really long way away because they don't appear, they have all the characteristics of the Cepheid variables, but they're way too dim. So on this next slide, where again, this is a much higher magnification view, we have Hubble, this is Hubble's eureka moment. It's his Cepheid discovery in Andromeda, and go ahead and read this.
In 1923, Edwin Hubble was examining photographic plates of the Andromeda Nebula taken with the 100-inch telescope in order to find nova, stars that would suddenly increase in brightness. On October 5th and 6th, 1923, Hubble located 3 nova, each marked with an N. One of these nova turned out to be a Cepheid variable, a star that changes predictably in brightness, and the N was crossed out and the star was relabeled VAR.
Yeah, this is just incredibly important. So here's this little nova, and it's crossed out, and it's a variable star with an exclamation point. Oh my God, what have I discovered? So in this next slide, there's a little notation at the top that says this is the single most important slide in this presentation. Pay attention to this one, because the Urantia book borrows Hubble's eureka moment to tell us how big that a superuniverse that Orvonton must be. This is without question the defining phraseology in the Urantia book to hold on to.
In one group of variable stars, the period of light fluctuation is directly dependent on luminosity, and knowledge of this fact enables astronomers to utilize such suns as universe lighthouses, or accurate measuring points for the further exploration of distant star clusters. By this technique, it is possible to measure stellar distances most precisely, up to more than 1 million light years. Better methods of space measurement and improved telescopic technique will sometime more fully disclose the 10 grand divisions of the superuniverse of Orvonton. You will at least recognize 8 of these immense sectors as enormous and fairly symmetrical star clusters.
Yeah, I can't tell you how long I've been reading the Urantia book before I stumbled across this. And even though I have a background in physics and astronomy, for some reason I had not noticed this paragraph, which is an exact replication of what Hubble's work was about. And I've just walked you through it. We've learned about variable stars, and this is a description of the variable stars as they are described in the paragraph. And he's saying that, the Urantia book is saying that Hubble's technique is accurate out to 1 million light years, which happens to also be the distance to Andromeda. So the Urantia book is validating exactly the work of Hubble and saying it's correct. His work is correct. There's nothing faulty with Hubble's work. And on top of that, they're saying that better methods of space measurement in the future and improved telescopic technique will then more fully disclose the 10 grand divisions of Orvonton. So it's a no-brainer. It's clear. We now have those better methods of space measurement. We have the better telescopes. And the better method of space measurement is type 1a supernova. Those are used now to replace the use of Cepheid variables in farther away galaxies. And the Urantia book is saying that now that we have those new improved techniques, we can look and we can document how far away other galaxies are. And now that we have that, we can see the 10 grand divisions, the 10 major sectors of the superuniverse of Orvonton. So the whole point here is that the superuniverse of Urantia has to be way, way, way out beyond Andromeda. Andromeda is just the beginning of penetrating the size of the superuniverse of Orvington. And if Hubble's work is just the most important work that was done in astronomy to tell us how that the universe consisted of, you have to remember here that at the time of our grandparents, there was only one galaxy in the universe, and that was the Milky Way. The Milky Way equaled a galaxy. Remember, the term galaxy is derived from the Greek term galaxios, which means way of milk. And at the time of our grandparents, there was only one galaxy, and in one fell swoop, Hubble is telling us that there are millions of galaxies in the universe. So overnight, there was an enormous change. There was a paradigm shift. And the Urantia book is telling us that Hubble's work is accurate, and it was critically important, and it is critically important to our understanding of the size of the superuniverse. So here it is in 1938. 1938, Edwin Hubble writes a book called The Realm of the Nebulae. And Hubble, even at this time of 1938, which is 15 years after he's discovered the fact that these nebulae in the universe are not just fuzz patches of infant stars. There is something more. Go ahead and read this.
Today, the term nebula is used for two quite different kinds of astronomical bodies. On the one hand are the clouds of dust and gases, numbering a few score in all. These have been called galactic nebula. On the other hand are the remaining objects, numbering many millions, which are now recognized as independent stellar systems. These have been called extragalactic nebulae. Since nebula are now known to be stellar systems, perhaps they should be designated by some other name which does not carry the connotation of clouds or mist. The proposal most frequently discussed is a revival of the term external galaxies. The authoritative definition of galaxy is the Milky Way.
So, so the thing to observe here is, if Hubble is struggling in 1938 to figure out what to call things, think of the trouble the Revelatory Commission had as they were formulating the language of the Urantia book. What are we going to call these objects? How do we name them? We want a name that's going to stand some test of time, but at the same time we must use the constraints of current language usage of the 1930s. So here we are 70 years later, and we are stuck with the baggage of old usage that needs to be translated into the present time. So with the marvelous usage of the language of the Urantia book that we just adore, there's a problem in very specific ways with some usages.